In this paper, we investigate asynchronous shared space learning in an immersive virtual laboratory that supports the instructor's recording of a demonstration and students learning from the demonstration. We have designed and implemented spatial-temporal assistive toolsets in virtual laboratory and analyzed the learning behavior of students to formulate the design guidelines applicable to generic virtual laboratories. Conventional immersive virtual laboratories are designed as a self-learning tool with a combination of text-based instructions and instructional videos, which removes the instructor from the entire process. Hence, the absence of the instructor may downgrade students' learning experience in virtual laboratories. To elaborate the advantage of learning by replicating instructor, our research explores virtual laboratory in the civil engineering context of unconfined compression test to determine the effectiveness of having an instructor's virtual avatar comparing to the other assistive toolsets. We conducted the requirement study to gather the design requirements and explore the best technique for demonstration in the virtual laboratory. We directly compared 3 demonstration techniques: video, avatar, and shadow. From the requirement study, we designed spatio-temporal assistive toolsets to prevent mistakes and improve the student's experience. For temporal assistive toolset, we add an autopause and a checklist features to the virtual laboratory. Each entry of the checklist is associated with the keyframe shows on top of the progress bar. When the playing records reach the keyframe, the record is automatically paused, and the students have to finish the task and tick the associate checklist to continue. We also integrate save and load checkpoint into the checklist system. Whenever the checklist is ticked, the system saves the current state of laboratory. The students can load the saved state by selecting the associate keyframe on the progress bar. For the spatial assistive toolset, we superimposed the instructor's semi-transparent workspace over the student's space in order to reduce the attention split between spaces. The superimposed workspace would allow the student to replicate the actions, locate objects, and compare their progress with the instructor. To support learning from different interpersonal distance, we replaced the teleportation in the recording with the walking animation to create an illusion that the instructor is walking around instead of teleporting. We believe that it would help students track the movement of the instructor. We conducted a user study to compare our design solutions and study the effects of these toolsets in terms of the students' learning performance. 24 participants were recruited from the local university. We used the VR recording system to record the participants during the tests. And this is one of the recorded participant in our user study. Please see our paper for the detail.